Hi, today we're going to talk about quadratic functions. So a quadratic function has the correct form, which is f of x equals ax squared plus bx plus c, where x has to have the square. So the degree of the quadratic function has to be 2. The coefficient of x squared is positive if it's concave up. So if it's concave up on your graph, it will look like this. So it will have a minimum value for its vertex. If it's a concave down, if the x squared is negative, then it will have a maximum value for the vertex. A vertex is the maximum, minimum, or the turning point of your curve. If we look at the equation y equals 3x squared minus 5x minus 1, we look at it and we say, is it a quadratic function? Well, the answer is yes, because the highest power is 2. So, not the highest power, but the power is 2. The highest, it has an x squared. So, if so, is it concave up or concave down? So, since it is positive, it's going to be concave up. So, it's concave up. Since the 3 is positive. Is the vertex a minimum or a maximum? If we look at our graph there, it will have a minimum point because it was concave up. So those are questions you can answer without even graphing it. Let's graph it on the calculator and use standard view. If you put it into your y equals, let's get rid of that. It will be 3x squared minus 5x, 3x squared minus 5x minus 1. And we're going to graph it. I'm going to do zoom. My windows are going to be negative 10 to 10. And as you see, it's concave up, and it would have a minimum. So does this show the complete graph? In other words, does it show the shape of the graph, the vertex, and how the graph opens? So yes. So if we were to draw a sketch, anytime you draw a sketch, it doesn't have to be accurate. But this is about how it looks like. We will find the all the critical points in a minute. Yay. So this says when graphing a quadratic, the larger coefficient of x squared, or the a, the larger the coefficient of x squared, the skinnier the graph is going to be. So if we graph y equals x squared, then if we said that x was 2, y would be 2 squared, so it would be 4. Four. If we said that x is negative 2, y squared would also be 4. Is negative 2 times negative 2, and it would go up like this. On y equals 3x squared, if we said x is 2 again, then y would be 2 squared, which is 4, times 3, which would be 12. So it would be all the way off of our graph. So let's go with 1. So if we say that if x is 1, y is 3, and if x is negative 1, y is also 3. So you can see how that graph is skinnier. So the higher the value of the coefficient of x squared, the skinnier the graph's going to be. If we look in our calculator, let's graph y equals x squared, and let's graph y equals 3x squared. And we see there's the first one, and there's the second one. It's skinnier. So other forms for quadratic formula is vertex form. You have y as a times h minus x minus h squared plus k, where the vertex is hk. So the axis of symmetry goes through the vertex, so the equation would be x equals whatever h is, the value for h is. So consider the function x minus 2 squared plus 3. How does it open? Well, the coefficient here is a 1, and it's positive, so it's going to open up. What is the y-intercept? In order to find the y-intercept, x has to be equal to 0. So if we go, so when x equals 0, we get the y-intercept. So I'm going to plug in 0 for that. So I get y equals 0 minus 2 squared plus 3. You can put that right in your calculator. I can quit. If you said parentheses 0 minus 2 squared plus 3, you get 7. So your y-intercept is 0, 7. I'm going to plug that in right now. There's y 0, 7. Does this graph has an x-intercept? If it does, then y equals 0. So 0 equals x minus 2 squared plus 3. I'm going to wait to see when we graph it if it has an x-intercept. I don't want to do the whole foiling and I mean, we should. Let's do it. So if I have, let's move this down. I need some space. I'm going to take the 3 over, minus 3. So I have negative 3 equals x minus 2 quantity squared. If I take the square root of both sides, oh no, I notice I can't take the square root of a negative number, so there's going to be no x-intercept. Because you can't take the square root of a negative number. If that inside was going to be a positive, then I could then I would have an x-intercept. If it was 0, my x-intercept would be, I would also have an x-intercept. So find the vertex and the graph. When we find the vertex of it, the vertex is hk. So if we look up here, the vertex would be 2, 3. Because of the equation. And write an equation for the axis of symmetry. The axis of symmetry, the vertex goes, it's going to be x equals, and then whatever your value for x is. So x equals 2 would be the axis of symmetry. So if I were to graph that, I would find the vertexes at 2, 3. So I'm going to go over 2, up 3. And that's also the axis of symmetry. X equals 2. So here's my axis of symmetry line. And my curve would go like this. It's symmetrical on both sides. So see how this is 2 over? This is also going to be 2 over from that axis of symmetry. So there's my graph. Let's see if we graphed it correctly. You go to your y equals on your calculator and go y equals parentheses x minus 2. n parentheses squared plus 3. And I'm going to clear this one out, and I'm going to graph it. If I want to check my vertex, I'm going to go to second graph, and I'm going to calculate the minimum and it asks my left bound, so the left bound has to be on this side of the curve, and it is, so I'm going to push enter. I don't care where it is as long as it's on the left side. Then it asks for right side, so see my cursor's going over. That's on the right side of the curve, and then it says guess between those 2 points. Yes, please guess it. And they told us that it is 2, 3, 1.999, but it is 2. So we know that our graph was accurate. That's how we check it. Check in the calculator, see if your graph is accurate. Woo! All right, so if we do this, f of x equals -3 with x minus 4 squared minus 7. What is the vertex? The vertex is hk. Oops. Hk. So the vertex is 4, -7. So I'm going to graph 4, -7. If I go over 4, down 7, that's my vertex. It's going to open down. Because that's a -3. And then the axis of symmetry would be x equals 4. So it's going to go along. This is the axis of symmetry. My dots do not look good, do they? They're going to go up that line now. That's as best as I'm going to do. But that's where x is 4. And since it opens down, it's going to go this way. Because it's a 3, it's going to be skinny. So we could actually be a little bit more accurate. And we can go skinnier. So let's check that on our graph. If we go y equals, and we say -3, parentheses, x minus 4, parentheses, squared, minus 7, and we go graph. Oh no, what did I do wrong? Hold that thought. Found where I went wrong. See in my calculator? I have the x there. I'm going to change that to squared. I put an x instead of a square. Let's see if that worked. There we go. So let's see if our vertex is 4, -7. I'm going to go to second graph so that I can calculate the maximum now. And the left bound is there. So we're going to go to the right bound on the right side of that curve. Second trace. Maximum. The left bound I'm going to say is over here. And the right bound I'm going to say is over on the other side. And then I want it to guess it, and it says, hold on, second trace, maximum. The left bound I'm going to put where x is 1, because I know that it's on the left side of that. The right bound, I have to make sure that it's, I know that the axis is at 4, so the x has to go at least to 4. So I put it where x is now 6. And then when it checks it, it says it is at 3.99999 and -7, which is 4 and 7. Whew. It might be easier to find that. Like, this is a tiny graph. might be easier to change your windows. Since you know it's going to be down there, you can say that x can be 0 to 10. Oops. X can be 0. X can be 0 to 10. But y, I'm going to say, is going to be 0 to negative 20. And we'll go up by ones there. Let's go up by ones. Scale 1, 0, negative 20. Go up by ones. Oh, go to the error. Window range is off. So 0 to 10 by ones, and 0 to negative 20 by ones. 0 to 10. My window range is in error. So window, my x minimum and maximum are 0 to 10. My y minimum and maximum are 0 to negative 20. Let's go from 1 to negative 20. It says the errors in my window range. I'm not sure why. Oh, because I have my minimum. I'm not doing well today, guys. So my minimum is negative 20 to 0. I had it backwards. And there's my graph. For now, I can go to second graph because now I can tell where the minimums and stuff are. I want a maximum, and I want to start on the left side because it says left bound, and then it says right bound. So I'm going to go over to the right side, and then I want it to guess between those. You see those? It's going to guess what's the maximum point between those areas. Go ahead and guess, and that's where you get the answers from. So we know we are okay. On the next one, you can pause the video at any time and try doing it. The next one here, I know that I am going to graph this using my vertex. My vertex is negative 3, 5 because it's HK. HK. But remember the original equation has a minus sign here. So I know that it's now negative 3. So my vertex is negative 3, 5. And then I know that it's going to open, this is positive, so open up. So it's going to open up. And my axis of symmetry is where x equals negative 3, because it's negative 3. And then I'm going to check in my graph, and I'm going to go y equals, and it's going to be 2 parentheses x plus 3 end parentheses squared plus 5. And then my window, if you notice here now, my window is in between the negatives, so I'm just going to do negative 10 to 10 again. And you notice that our graph looks just like that. And if I want to find the minimum value would be, or the vertex, that's my minimum. I'm going to go to calculate the minimum. And my left bound has to be before, because I already know what it is. It's negative 3, 5. So the left bound has to be before negative 3. So I'm going to go to negative something else. Right now it's at x is 0. So I'm going to go to where x is negative 1, 2, see it up here now, 3. I'm looking at this right here. So now that that's on that side, I'm going to push enter, and then I'm going to drag it to the right side. Press enter, and then it says guess between those two. Yes, please. And there's our point, negative 3, 5. So we get it right. Ooh. Okay. So consider the function f of x is 5 with x minus 6 squared minus 2. Give the coordinates of the vertex of the graph and graph the function in a window that includes the vertex. So the vertex, how does this open? We think about it. It opens because of 5 is positive. So it's going to open up. Are there x-intercepts? Let's find out what our vertex is first. And you can tell because if it goes below the x, if it's a negative value for y, then you definitely have x-intercept. And what is the y-intercept? The y-intercept is when x is 0. So x is 0, we're going to substitute it in for this and do the math. So we have 5, 0, minus 6 squared minus 2. And that's going to give us our y. So if we go second quit in our calculator and we put exactly what's in there, 5 parentheses 0 minus 6 parentheses squared minus 2. And then our y value is 170. Wow. 8. So it's going to cross the y-axis at 0, comma 178. We don't have to graph that part of it, but we'll know now that our window has to go up to 200 maybe, right? So then it says, let's find the vertex. It equals hk. Remember that k was supposed to be, this sign's supposed to be positive in the original. So the vertex is going to be a positive 6 and a negative 2. So if I go to my graph, I go graph y equals, I'm going to say 5 parentheses x minus 6 parentheses squared minus 2. And I know that the graph has to go to 6, negative 2. So a negative 10 to 10 graph window is fine. And when I do my graph, you see the vertex is 6, negative 2. And then if it asks for my x-intercepts, we could actually find those x-intercepts by doing the quadratic formula or by doing it in your graph. If you're doing it mathematically, x-intercepts were y equals 0. So it would be 0 equals 5x minus 6 squared minus 2. I'm going to bring the 2 over, so I have positive 2 is 5x minus 6 squared. I'm going to divide by 5 to get rid of this here on this side. When I divide by 5, I'm going to do 2 divided by 5 in my calculator. Just so that I can get a decimal, because it's probably going to be easier to work with than a fraction. So I have 0.4 equals x minus 6 squared. When I take the square root of both sides so that the squared goes away, then I have the square root of 0.4. So the square root of 0.4 is something crazy. So I'm just going to say the square root of 0.4 equals x minus 6. Because since that was squared, I can take one of them out. And then I'm going to add 6 to both sides. So I had the square root of 4, 0.4. And remember that when you take the square root, it's going to be plus or minus. So I have 6 plus or minus the square root of 4 is my x-intercepts. So when I do 6 plus the square root of 4, the square root of 0.4, I get 6.63 something. And then if I do 6 minus the square root, Then I get 5.36. So those are my x-intercepts, comma 0 when y is 0. If I go back to my graph and I want to make sure that is, I can go to, I want to graph, no, I want to second that, and I want to find my zeros when y is 0. So my left bound, I'm going to go before where x is, see how x is 0 now? I want to make x, it could be the left bound, but I'm going to come closer to my thing. See, there's that one. Ooh. And now I'm finding my 0, so I have to go above this line, so enter here, and somewhere below this line, so that's below, and I want to find a 0 there. And when y is 0, look, we have 6.36 or 6.63, so that's 1. I can't read. That says 5.36. So that's this one. And if I want to get my other 0, I'm going to calculate my zeros again. And this time I'm going to go under as my left, and then I'm going to go above the axis, because I wanted to calculate that second 0, and there's where I get 6.63. So yes, I do have 2, and you can do the quadratic formula for it. You can do, I just did the differences. I took the square root of both sides and did it algebraically, or you could use your calculator. What? That was awesome. Here we go. If a quadratic is in standard form, use the formula opposite of b over 2a and opposite of b over 2a. So if you think about it, this is your x value, and this is your f of x value, which is your y value, to find the vertex. So with a, b, and c, what is the vertex? If the vertex for x is the opposite of b over 2a, we have b equals 6, a equals 3, and c equals 29 negative. So if we want the vertex, A, B, and C. Opposite of B over 2A is opposite of 6 over 2 times 3 for my x value. And my y value is the opposite of B over 2A. Oops, wrong thing. Sorry. So to get x, you would do the math there, and you would have, so then the x would be negative 6 over 6, which would be a positive 1. I mean a negative 1, sorry. And then for your y value, it says f of whatever that is. So this is when x equals negative 1 for your y value. So I'm going to plug in negative 1 here, negative 1 here, and negative 1 here. So, but just kidding, there's no x on that 29. So I'm going to say y equals 3 times negative 1 squared plus 6 times negative 1 minus 29. So if I look at that, I'm going to go to my calculator, and I'm going to put in 3 times parentheses negative 1 squared plus 6 in parentheses negative 1 minus 29, and I'll get negative 32. So my vertex would be negative 1 negative 32. So find an equation for the axis of symmetry, x equals negative 1. And then does it open up or down? It's going to open up because 3x is positive. 3x squared has a positive 3. So let's check our calculator. Let's put it in our y equals. So y equals 3x squared plus 6x minus 29. And then I'm going to go to my window and I'm going to correct my window. And I choose negative 50 to 50 because my vertex is negative 32. So I have to at least get that far. And so I might as well make it a perfect square. And I'm going to go up by tens just so that I don't have a whole bunch of little lines on my axis. And when I graph, I have this. And I'm going to double check to make sure that that's where my line crosses down there. So I'm going to find the minimum. Go to second trace, minimum. I'm going to start on the left side of that loop. This is my minimum. Yeah. So there's my dot. So I'm going to start from there. Over here. Anywhere over here works because I'm trying to look for what that point is. So now it's between those two. I'm going to say, yeah, I guess between there. What's my minimum? And there I have it. Negative 1, negative 32. That is awesome. I want you to do the one on the next one. Oh, what's the y-intercept? We could find the y-intercept by doing the zeros. Oh no, by doing over here. Actually, the y-intercept is right here. When the y-intercept x is 0, so it's negative 29. 0, negative 29 is the y-intercept. All right, find all that information on this next equation. Y-intercept is easy. Up or down is easy. So it opens down, right? Concave down because of this negative, because of negative x squared. And what is the y-intercept? The y-intercept is when x is 0. So the y-intercept is 0, comma 1000. So now your window, when you go to check, your windows are going to go to like at least to 1000, right? So I'm going to do from, and it's going to open down. So I'm going to do to 2000. So my windows here now, I'm going to go from, I'm just going to go from 0. Oh, well, x, I'm going to go from negative. Let's find out what the vertex is first. So what's the vertex? The vertex is the opposite of b over 2a would be my x value. So my x value would be the opposite of b, which is 140, over 2a, which is 2 times negative 1. So it's 140 over negative 2. So it's going to be negative 70 is my x value. And I'm going to put in negative 70 for x because my f of 70 then is going to be negative 70 squared minus 140 times 70 plus 1000. So I'm going to use my calculator, of course, and I'm going to go second quit, and I'm going to go negative 70 squared minus 140 times 70. It's negative 70 though. So times negative, nope, it's positive 70. Nope, it's negative 70. So times negative 70. Put that negative sign in there because that matters. And then plus 1000. And we get that number. Wow. Wow. That's insane. I'm going to pause the video and make sure that that's right before we continue. Okay, found my error in my calculator. I put an X there instead of a square. So I went back through and put a square there, and I have 157,000. So that's a lot, 700. So that's my vertex. My vertex is then -70 and 15,700. But so I'm going to do my window because it's such a high number. I'm going to go to 20,000. So I'm going to go from on my X. I'm going to go from, because it's -70. So on my X, I'm going to go from negative 100 to 100 by tens. And on my Y's, I have to get to 157, 15,700. So I'm going to go to 20,000. Negative, I'm going to go from 0 to 20,000. 0 to, I'm going to go from 20,000 to 0 by thousands. Whew. Okay, window error. Let's see what I did. Window error. I have a minimum to a maximum. Cool. And I have a minimum. My minimum and maximums were opposites. So I could make it 0 to 20,000. I'm going to find my minimum here because that'll be my vertex. My left side is, oops. My left bound, I'm going to say, is on my X is negative 100. And my right bound is 100. I have to go at least to 70. Oh, look at that. Oh, my calculations are off. Okay, I'm going to pause the video, figure that out. Okay, found my error again. Right here, in front of my 70, that big equation, notice how online it says negative x squared? Well, right here, I don't have negative there. So I'm going to second insert a negative. And now it's 5,900.